there. This is another video lesson from the Mathy project. This lesson will be about definite integrals and the application of the fundamental theorem of calculus. So, let's speak about it. The fundamental theorem of calculus is the theorem that we need to use to evaluate definite integrals. And what gives this theorem to us that allows us to obtain the definite integral? First, we need to have a closed interval or a closed range of the form AB. Then, we need to prove that the function that we want to integrate is a continuous function on this range. And finally, we need to obtain an integral of the function f. Knowing this, then we can state that the definite integral between a and b of function f will be equal to the integral of function f evaluated in a and b as this. First, we replace x by b and minus, and then we replace the capital F x by a. So, using this theorem, we can solve some definite integrals. Here, we will present some examples or some exercises. So, we want to evaluate the definite integral between 1 and e of function 1 by x. So, using the fundamental theorem of calculus, we can state that the function f must be continuous on the interval 1 by until e, the closed interval. And this is true because the domain of this function is the real numbers except number 0, and since this function is continuous on its domain, of course it will be continuous on the interval 1 to e. So, we already proved that the function is continuous on the interval. Then we need to see if we can obtain an integral of function 1 by x. So, to do this, let's try to integrate the function 1 by x. Then, as you can see, the integral of 1 by x is natural log of the absolute value of x. And applying the fundamental theorem of calculus, we need to evaluate this on e and on 1. So, substituting x by e, we obtain a natural log of e and minus the natural log of 1. Since the last one is 0, the value will be 1 because log of e is 1. So, we obtain the final result for this definite integral. The next example is to evaluate the definite integral between 0 to 4 of x plus 1. Then we need to state the same as previously in the previous exercise. So we have the closed interval between 0 and 4. the integrand function is the polynomial function x plus 1, and since it is a polynomial function, the domain is the real numbers, so that the function f is continuous on the interval 0 to 4. Then, knowing the integral of this function, and it's easy to obtain the integral of x plus 1 because it will be x squared by 2 plus x plus c, then we can apply the fundamental theorem of calculus. So we will obtain this expression, and finally we need to replace first number 4 and then number 0 as this. And we will obtain f of 4 minus, and replacing x by 0, f of 0. Then the final answer will be 12. Thank you for watching.